topics are finding areas under irregularly shaped curves and then taking curves and rotating them around axes and finding the volume. So conceivably you could find the volume of a football, even though I don't really know what the function is that creates a football. I'm sure there's some function. They're all the same. So I'm sure they have something that models that. So my question for you is, these are little rectangles. Can you find the height of this rectangle? How'd you get 6? 8 minus 2. Now, if you wanted to find the area, you would multiply the base, which is delta x, times the height, which is 6. That's the, well, we won't get there yet. How about this one? What's this height? 5, because it's 5 minus 0, so that's just 5. Now be careful with this one. How big is that one? How'd you get 4? Or, if you don't want to break into 2 rectangles, this is at 3, this is at -1. What could I do with these? Okay, subtract them. So to find the height, what do you do with the y values? You subtracted them, right? So what's this going to be? B minus A. So the height's going to be the difference in the y values. And what would the base be? This would be the change in what? X. Notice the variables. They are different. The delta x determines the variable that we'll be working with. Okay? But because these are perpendicular, the height and the base, I should label that correctly, that's area, will be different. They're always going to be opposite. I kind of like those always statements. Okay, so that's what we're doing, and we're not going to work out of the book. We're going to work out of this big yellow packet today, and we'll be finding the areas. Okay, I could even start with the back and go, because that's last year's. In the last 2 years, at least the last 2 years, it was without a graphing calculator. You don't have it yet. It's still not necessarily in order. Now, you guys, there's always an area volume problem on the exam. I have never seen a time when it hasn't happened. Not to say that there's not a first, because there could be a first. But I kind of like those. Okay, let's review a little bit. We should all know what a differential equation is. Jimmy, do you remember what it is? No, I'm still not hearing Jimmy. First off, it's an equation. Okay. Zach, which involves what? Derivatives. Because you're going to have a differential equation, at least one on the exam, and you better know what it is. Derivatives, whose solution is a function. It's not a number. When you solve equations, you get numbers. This time I'm going to get a function. What is an integral? Careful with the areas. Partly area. It's a signed area. Very good, Adam. But if I really want to find the area, the actual area, I have to be careful. I'm going to use an integral. I can use absolute value depending on what it is. But this has been in the non-calculator section. So if they were to give you a problem that would involve having to do with negative functions, they would give you the picture. They would give you the diagram. So we're going to look at this, and we're going to do some things by hand, and we're going to do it with the graphing calculator. We're going to find the area under the curve from x equals -1 to x equals 2. So -1 is right here, kind of. There. So I want that area. And guess what I'm going to do? I'm going to do a Riemann sum. I'm going to add up the areas of all the rectangles. Okay, you guys in the front? Put that away, please. So I'm going to draw in rectangles here. I don't care what kind they are. If they're over, they're under, it doesn't matter. Because I'm going to put a whole bunch of them together. I'm going to put an infinite number of rectangles. And remember how we did that summation? What's the area for one of these rectangles? It's base times what? Height. And the base we called delta x, and the height is the y value, or the function. I like to keep it as y's personally, because then I'll switch over to the right variable. So when you, well, we'll get there. So this is y, or f of x, times delta x. Remember that as a Riemann sum? When they ask you for a Riemann sum, they're asking you for this, but they're going to give you 4 rectangles. That's all. They're just saying, find the area under the curve. Could be a signed area, depending on how they're asking it. The normal Riemann sum is a signed area, and n is going to start at, I is going to start with 1 to n, and this is f of x sub I. That's the formal definition. And Riemann, of course, said, I don't want to write that out every time. Notice this is just geometry. I'm going to find the area of each one of these little rectangles. I don't care how you divide this up. They can all be different sizes. I can have all different sample points. The only condition is that the biggest one, that area is going to go to 0. If the biggest area goes to 0, then they're all going to go to 0, but they're going to still be adding up. And so he wrote this because he said, I didn't want to write all this. I'm going to write this as an integral from a to b of f of x dx. So an integral is a signed area, but I can also use it to find the actual area. And if you haven't caught this before, because some of you say, well, what happens when I integrate? What happens to this dx? Well, this with this little symbol means find the antiderivative, which we never proved. We just told you that's what it was, Adam. But that's also the base of my rectangle, isn't it? So if you write an integral without the differential here, you're in trouble. You can be in trouble. I see a lot of those when I grade the exam. We do not mark it wrong. However, the students usually get the problem wrong because the differential tells you what variable you want in your problem. And if they don't have a differential, then what am I supposed to do? Do I want x's or do I want y's? And you're going to say, well, we'll always have x's. Maybe, maybe not. So let's write an integral for this because I'm going to add all these up. So what do we get? So we're going to integrate. And we'll get the limits of integration first. What's the height of my little rectangle? Okay, I'm going to call that y1. I'm going to do this really slow. And what's the base going to be? dx. So my function was y equals x squared plus 1. You'll see why I'm doing this in a little bit later on. What variable do I want in my problem? Do I want y or do I want x? I want x. I don't want 2 variables there. I don't know what to do with 2 variables, Natalie. I want to keep just the x's right there. So guess what I'm going to do? I'm just going to substitute y in there in terms of x. And so I'm going to get the antiderivative of x squared plus 1 dx. And now let's put the limits in. What are the values going from? -1 to 2, right? Is that any different than what we've done? No, it's the same thing. But don't forget my function's above the axis, so we'll have to deal with that in a second. Now, will you remember how to use the calculator? But let's integrate this by hand. Am I going to do a u substitution? No, because properties of integrals say that I have this, -1 to 2 of x squared dx, because I can distribute an integral over a sum. Guess what? I can't distribute it over a product. Some of you would like to do that. Emily might have seen some with triple integrals and multivariable, probably. Plus, it's been a long time for me. -1 to 2 of 1 dx. Okay, so what's the antiderivative of x squared? X cubed over 3. Now this, on the exam, would be a problem like this, where you can do it by hand. From -1 to 2. What's the antiderivative of 1? X. So if you go back and look at the most recent exams, that's probably what you're going to see on the exam. The ones before that were on graphing calculators. They took it off the graphing calculator section because I guess there's some calculator, and I don't believe it's the TI, that actually you just type in the formula, x squared plus 1, and it sets it all up for you. Maybe it's my Riemann sum program. I'm not sure. So that's why it's not on the graphing calculator, because it's not equitable. Because not everybody has the program or the ability to do that. Okay, so we substitute this in. So it's 2 cubed over 3 minus, do I need parentheses when I substitute a negative? I really need it with a positive too, but I'm usually lazy. Cubed over 3 plus, and then we're going to substitute this one in, which is 2 minus 1. And we have problems with this because of the fact that we don't use the parentheses. Now, if this is free response, that's good enough. It's probably multiple choice, so it's not good enough. What's this going to give us? 8/3 minus 1/3 plus, plus 1/3, thank you, plus 3, which is, that's why I'm free response. I would leave it like this. Well, what's 8/3 plus 1/3? 9/3, which is, so we see if we did it right. Do you remember how to do this on your calculator? Does anybody need a calculator? Okay, the syntax is FNINT, if you're on the old one, and then you put, I always put my function in Y1 because there are too many parentheses. So it's Y1, or the function. Now on the exam, you get no points for writing this out, comma X, and it's from A to V. And we could store that in Y0, which is the 10th one, and just turn it off, and then you always have it there. What you get your points from is all of this. You do not get your points from using a calculator. Now, if you have a CAS calculator, be careful. Because all you're allowed on the exam without supporting evidence is finding zeros, intersection points, numerical derivatives, and numerical integrals. Some of you with a CAS calculator will say, well, I can just integrate that with my CAS calculator because it'll find the antiderivative. And you will lose points because they want you to do the calculator. So that's the problem. Okay, so I don't know what that is. And in Y1, I'm going to put in, can you guys see that? X squared plus 1. I can barely see it. I just prefer to keep it there. And if I quit now, I'm going to go under. Now, you could do in the graphing screen. I just find that if I don't have the right window, I'm in trouble. So that slows me down. So I'm better off doing this. FNINT. Now, there are shortcuts for those. You have the new operating system. That's the numerical derivative. This is the numerical integral. And mine's going to be in pretty print.
Wait, which order does one go? It goes X, Y?
That one. It's Y, comma, X, comma, A, comma, B. If you're in the new operating system, or if you don't have it, you can get that from me. If I go back to regular old classic, I still get this. So it hasn't solved. I know Ms. Erzman doesn't get that. This is -1, right? I just do it in this order to 2. If you have a CAS, it's typed in exactly the same way. And then I'm going to pick up Y1. It's in vars. Do you remember how to get that? Y variables. It's a function, and I'll pick up Y1. And then you have to tell it the differential. So I don't know why you would not put the differential on the exam. And that could change at any time. Just because they haven't counted against you in the past doesn't mean they might not in the future. And I got 6. Did you put your function into Y1? By the way, where else can you pick up Y1? You go alpha and then press this trace button and Y1. These are just shortcuts here. And the other shortcut is alpha, the window. I just play around with it until I find it. And there it is, FNINT. Is that okay? Okay, here's a little bit of a problem. I think I have the right graph on there now. Last year I didn't. find the area of the region bounded by the cubic, the x-axis. The area, when you find an integral, only goes down to the x-axis, and between x equals -1 and x equals 2. Because I'm going to do between x equals -1, that's an intercept, and x equals 2 is our line. And I want this area under this curve. And you know what? I want to make sure I have that graph right. I'm not convinced I do. What was that? X cubed minus 3x squared? I think, because I know I used to have a problem with it. I don't know if I fixed it. So we will put it in. You guys still need practice with doing antiderivatives. So you should do things by hand because you need that practice. And you will be expected to do that on the exam. I know I used to have a different one. Okay, I'm going to zoom it 4 because I get nice numbers. Yeah, my picture's not right. Notice where that is? Now, you remember how to find zeros? Is that a 0? We do a second, calculate. Because my picture that I put in here is wrong. It's off a little bit. I want to find that 0. Because right here, it doesn't look like it's at 1. Here it does. So I'm going to go press enter, and then I'm just going to arrow over till I'm past that point. Notice it's going to say sign. I'm going to go negative. It doesn't say sign change, but it has to change signs. And there it is. So my graph here isn't quite right. And I will make that bigger. There, that's a much better graph. Okay, so we're going to go from here to here, which is 1, and that's at, what, -1, right? And then we're going to go from -1, we're going to stop at 2. So what does that look like? You can write out the rectangles if you like. I just actually just go and do the problem. So it's base times height. What's the height going to be, the y or the x values? So it's going to be y times dx. So I'm going to go from -1 to where? 1 of y dx. And why can't I go to 2? What happens here? That becomes negative. And then I found what? Not distance, but displacement. I get the signed area. And then I'm going to do plus the integral from 1 to 2. But what do I have to do to fix this? I have to do a minus and that y value dx. So if I put this in here, it's -1 to 1. What was my y? Why did I choose to do this? Partly because could I solve this equation for x? I don't know about you, but I can't. 3x squared minus x plus 3 dx. And then it's minus this integral, x cubed minus 3x squared minus x plus 3 dx from 1 to 2. Is that okay, Olivia? It's not too bad to do. Do you want to integrate it by hand or do you want to do it on the calculator? What rule am I going to use for all of these? If you can't tell me the rule, then we should do it by hand. The power rule, right? That would be x to the 4th over 4 minus x cubed minus x squared over what? 2 plus 3x. Now, if I really want to make my life easy, what's another way I could do this? If you did the homework, you'll know. I can integrate from -1 to 2 of x cubed minus 3x squared minus x plus 3, provided I do what? Put it into what? Absolute value. So if this were your velocity and they asked you for your speed, you'd have to absolute value that. Should we try that? You can, but guess what? I'm going to put into, well, I already have this in y1, don't I? Jimmy, you have a question? And there's y1. Well, let's see if it's right. Here's a calculator. It doesn't take very long. Anybody need a calculator? I got a whole bunch of extras. Okay. I'm going to clear that out, and we're going to go to math. Should we use the shortcut? Which is your integral, which is 4. It still looks the same. It's n derived. It will go from, the request was to do it in the pieces. So it's -1 to 1. And this was y1. And the shortcut is alpha trace y1. You know, does it save me that much? I don't know. Okay, Adam, what'd you get for this one?
0.5.
I have no idea what it is. That's 4. I'll put it over here. And then what do we have to do? We have to integrate the negative of that from where to where? 1 to 2, right? Well, you can go, if you have to do this, you would go second, enter. Now it lets me go back. Actually, I prefer to do that than going back. That was a 2, right? And this was a 1. Whoops. I could. That was 1, that was 1 to what? 2. Don't ask me what I did there. Now, I know I hit the wrong button. That's okay. No big deal. You have to be able to do it by hand. Clear. 1. Now, I should get a negative number when I press enter, right? Because that's the underneath the curve. Negative 1.75. But what do we have to do with that? We have to make it adding. Oops, I guess I can put it right there. So this is, where's my picture? Oh, there it is. So it's 4 minus negative 1.75. You guys love your decimals. Personally, I like 5 3/4, but okay. Let's do the whole thing with absolute value. I want to see if I'm right. Guess what? I'm going to do this. I'm just going to go back up here and grab it. You could do second enter. And I want -1. Not forgiving with that negative sign. And now I have to put this in absolute value. I may have some problems here. Do you remember what absolute value is? Come on. Might have been just faster to type it again. Okay, so it's math, NUM. If you did the homework, you should know where it is. And it's the absolute value of y1. Bars, y variables, it's a function. We don't do anything with anything else. It's thinking 5.75. Now it's doing it numerically. That's why it's off a little bit. But we only need how many places? 3. Took a little longer with the absolute value. I kind of liked it better the other way. Okay, is this okay? Ask. I did this integral from 1 to 2. This is 4. This was negative 1.75. I can hardly see it myself. And if you, because we had to negative this, right? So 4 plus that. I didn't put my negative in there when I did it. I could have. Okay, ready? Adam, help me with this one. Yes.
Okay, well, first.
Whoops. Wait a minute, I had a question on this other quote. Sorry. What's your question?
Oh, I was gonna say, you know how in the last problem you had to find dx of it as well, find the y and the dx?
No, dx is the differential. It says this is the variable I want in my problem. You'll see in a second.
Alright, but we don't need like a y value.
That is y. This is the y.
I mean, a change in x.
That is the change in x. That's the base of my rectangle.
Yeah, but in the last problem, can we plug in 2 and negative?
I could have integrated this and plugged in the values. I used the calculator. I was lazy. Because that's not any math. It's arithmetic. Okay, so I want to make this bigger, maybe. And I want this region that is trapped between f of x and g of x bounded here, and I better label which one's which. It doesn't matter. We'll make this little one that looks like a sine curve, f of x, and we'll make this other one that looks like a parabola, g of x, and it's from x equals a to x equals b. X equals a, x equals b. How would you find this height? We just did a bunch of those in the beginning. What would you do with the two y values, Olivia? What would you do with these y coordinates? This is at 6 and this is at 2. What do you do with those to find that height? What do you do? Subtract, that's right. So I'm going to add them all up. That's what it says to do. Starting where? A and going to B. And which one do I subtract? This is f of x that's right here. Which one's above? So it's f of x and then minus g of x. Just geometry. The calculus is putting it into the integral and finding an antiderivative. And if it's a calculator problem, there is no calculus. You just use your calculator. All the calculus says is, I'm going to divide this up into a whole bunch of rectangles. How do I find the height of my rectangle? I take this y value minus that y value. That's all there is. So if you look at the exam problems, if it says set up but do not integrate, that's all they're asking you to do. And by the way, if f of x and g of x are clearly defined in the problem, that you know f of x is something and g of x is something else, in your setup, all you have to write is f of x and g of x. You do not have to recopy the function, which is nice. Okay? Yes? If you say f of x is this, yes. As long as it's clear. It's the same thing with when you know what a and b are, because they could be kind of nasty. Okay, I want the region bounded by this. Hey, Alexa, how am I going to do that? Matt, how am I going to do that? I want that yellow shaded region. Huh? Y negative 2. How do you know that? Okay, so we're going to have to figure out what these points are. Right now, I'll put that off for a second. I need to find that. And then if you have problems, draw in your little rectangle. How do you find the area of this rectangle? Well, the base is what? What's the base? Delta x or delta y? Delta x. Okay, Andrew, how do I find the height? Natalie? What do you do with this value and this value? These are which coordinates? X or y? Y. So that's y1 and this is y2. So here's the setup. I don't know where they intersect. But it's y1 minus y2, and the differential is what? They're always perpendicular. They will never be the same, dx. Now that's for any function. I don't know what the function is. I mean, I do, but that's any function. This tells me I want x's in my integral. So which one's y1? Got to be careful here. The line or the curve? The line. So it's x plus 4 minus the other one, x squared minus 2. How am I going to find where they intersect? You cannot read it off a graph. Okay, Adam? Can't read it off a graph. And I want the x's. So I'm going to set the y coordinates are the same at that point of intersection, aren't they? It's a non-linear system. That's a line, that's a curve. But it doesn't matter. These two y coordinates are the same. So x plus 4 equals x squared minus 2. And when I solve any equation, even if it's linear, I always set it equal to 0. Some of you like to do some crazy things. Just, it's got to be 0. Can we do this in our heads? 0 equals, well, I've got the x squared, and then I want to subtract x. So it's going to be what? Minus x. I have a negative 2, but I'm going to subtract 4. Minus 6. If you need to show the steps, show the steps. I want you to get it right. And so this will factor. What's that factor to give you? Does everybody agree? So x equals negative 2 to 3. Now, if it's a graphing calculator problem, you're probably going to have to find the intersection using your calculator. So don't assume anything. But if it's not in the graphing calculator section, then I don't know if they give you the picture. Negative 2 to 3. So should we integrate that? Well, before I integrate, would it be maybe nicer to simplify first? Because what happens with this minus here? This makes this adding, and then this is the opposite, and this becomes a what too? Positive. And that's where we kind of mess up a little bit. So, it's the integral from negative 2 to 3. I like to have my x squareds first. Minus x squared plus x, and 4 plus 2 gives me 6. Now it should be easy to integrate. Am I going to use a u substitution? No, I only use u substitutions if my integral does not look like something I already know of, those, what, 10. Because this was minus x squared minus 2. And when I distribute that, it becomes plus. And it kind of got obliterated in my writing. Okay, so this is minus x what? Cubed over 3 plus x squared over 2 plus 6x evaluated at negative 2 and 3. Do I need C on this? What kind of integral is it? Definite. The definite integral has a definite answer. Nothing vague. Okay, so let's substitute that in. It's minus 3 cubed over 3 plus 3 squared over 2 plus 6 times 3. And I'm using the parentheses because it'll never hurt me to put the parentheses in. It might hurt me to not put the parentheses in. So it's that one minus this one. Put in minus a negative 2 cubed over 3. I'll be okay. I'll get that one right no matter what I do. Plus negative 2 squared. Here I will not get that right. Plus 6 times a negative 2. If it's free response, that's good enough. If it's multiple choice, which it very well could be, then you have to do some work. Cancel what out? Let's do it, because we need a little algebra arithmetic practice. What's this going to give me? Negative 27 divided by 3 is negative 9 plus 9 halves plus 18. I'm going to be really careful with my signs because something tells me I'm going to mess it up. Minus, what's this going to give you? Negative 2 cubed is a negative 8. Times the negative is a positive 8/3. Don't get it confused with the negative that's out in front. Plus, 4 divided by 2 is plus 2. And 6 times negative 2 is negative 12. Should we go ahead and get rid of that minus that's out in front? Remember, you have to opposite everything in here. So it's plus, that's a negative, and this is a positive. And then I like to group things that are kind of similar if I can. I don't know if they are. Like these guys, what's that going to give me? 9 plus 9 halves. I want to do the fractions last. Minus 8/3 plus 10. And so that gives you 19 plus 9 halves minus 8 thirds. Do you care about the rest? Yes? No? Should we do it? That's my feeling. What's the common denominator? 6. Now, in math team, this answer would not be allowed. You have to have it simplified. So it's times 3 times 3. This is times 2 times 2. So it's 19 plus 27/6 minus 16/6. Be careful with that. It's 11/6, isn't it? Now, can I do 6 times 19 in my head? Sure I can, because you know what 19 is? It's 20 take away 1. Now, I can do this in my head. So it's 120 minus what? 6. So this is 114/6 plus 11/6. If you haven't done that trick, you might run into that in real life where you don't have a calculator handy. So it's 125/6. That's good enough. I know it doesn't reduce. 5 goes into 125. 3 does not go into 125 because if I add up the digits, 1 plus 2 is 3 plus 5 is 8. 3 does not go into 8. It's helpful on the SATs and the ACTs to know your rules. Okay. Let's try this one. Now make sure you know what the graphs look like. Okay. You should try this one, Adam. If you don't practice, I just really look good.
Yeah, ironic is actually good.
Okay, I know the intercept is 4 and then the bottom line.
So you want to slice it this way and integrate from here to there?
Yeah.
But I don't know where that is.
I figured it out.
It doesn't look like it's at 4. That's 1, that's 2, that's 3. So it's 2 something. And we'll find out. Okay, so you can integrate from 0 to A, and then integrate from 0 to A plus A to B. Or we could be smarter than that. Who says we have to slice it vertically?
Oh God, we're going to do.
We're going to slice it horizontally. Oh, nuts, I can't do that. What if we slice it this way? Now, you guys, be careful with this. So here's another slice. How do you find the height? It's sitting outside, though. How do you find this length here? What do you do with the coordinates? It's the change in x. Let's call this one x1 and this one x2. Which one's bigger, Adam? x1 or x2? Because it's further to the right. If you were to rotate this 90 degrees to the left, x1 would be higher. Because it's only one integral. I'll worry about the limits for a second. And then, so it's this x value minus that x value. And what's the differential going to be? It's delta y. Now, remember what I told you. The differential tells you what letter you want in here. I'm not going to put in the square root of x on that minus x plus 6. Okay, guys? I'm going to solve these equations for y and put those in there. And I see, if you don't have the differential, what I see happen is the students take this one minus that one. And that's not right. Here's the setup. Notice, I don't even care what those functions are. It's just the difference in the x-coordinates times the little thickness, which is dy. So this is, if I solve this one for x, I would square both sides, right? So it's y squared. What if I solve this one for x? Y equals minus x plus 6. If I put the x over here, it becomes what? X. And I want to get the y on the other side, right? Is that right? Now, I gotta think, which one's first? Hey guys, which one's first? Adam?
-6. Negative y plus 6.
It's the line, right? So it's negative y plus 6 minus the other x, which is what? Y squared dy. Do you see why there's a problem if I don't put the differential in? The differential tells me the variable I want. Because it's the one further to the right. This value, if you put a number here, that might be 8, and this would be 2. You see the numbers as you go to the right on this line are getting bigger. It's bigger minus smaller. Sometimes they might give you x in terms of y, and you have no choice but to do this, because you can't solve for y in terms of x. Okay, what's the next thing we have to do? Find where they intersect. Which values do I want, x's or y's? I want the y's. What's the first starting value on the y? 0. Now, I got to find out where these intersect. I could either solve the x equations or I can solve the y equations. It makes no difference. Personally, I think I'd rather solve the y equations. I think they're a little easier to do. Because what's true about the x values at where they intersect? They are the same, right? So this y squared has to equal minus y plus 6. I like those because that's a quadratic. Okay, so how do I solve a quadratic? Set everything, always any equation, set it equal to 0. So it's what? Plus y minus 6 equals 0. The problem is I'm going to have extraneous solutions because this is a parabola. When I do x equals y squared, it's really this one. Hey, Adam, did you get that? It's really a parabola on its side. We've restricted it just to be the top part of the parabola. So it's y minus 2, y plus 3. Do you guys agree? Sometimes I just blindly listen to you. Y is equal to 2 or negative 3. The negative 3 is where the bottom half of this curve would intersect that line. But we don't have that part. It wasn't given to us. So it's 0 to 2. What's the x value? Then my picture is probably not right. I might have been counting by 2s. I don't know. But that would be harder, because you would have to sit there and do 2 integrals. It doesn't matter, but sometimes you don't have a choice. I will bring in an example. No. Is that it? Okay.
I'm still lost why you did y instead of x.
Because it was easier.
That's too hard.
This one, come on, where is it? My board's off a little bit. Oh. Not quite yet. Where's my board? Where's my problem go? Oh, there it is. Because if I do the first one, I can integrate from here to here, and then I have to find the area of that triangle, which I certainly could do. Nothing wrong with it. Get the same answer either way. Okay, what's your homework? The yellow worksheet. You can do, not all of it. Okay, remember, now we are getting ready for the exam. It's a nice day today, but tomorrow's going to be nicer. You need to spend 30 minutes outside of class. Why don't we start at the very beginning, rather than going backwards? So starting at 2003 and then working forward. And on 2003, number 1, you can do A and B. On 2, you probably can only do A. This yellow packet that you don't have. Now keep in mind that how much time do you get for each response question on the exam? 15 minutes. So you probably get 5 of these problems done of just the A's. Now, if it's a problem 1, 2, or 3, except for recently, it's a calculator problem. Everybody know that? Next year, or in this year, when you take the exam, we'll leave problem 1 and 2. Are they? I don't think so. They're pretty thick. They're pretty thick. I would count of 3. This should be where it kind of gets exciting because we're starting to this is just AP problems. We're not going to do the book problems. We're going to get you ready by doing AP. If you want to do extra practice, then do the other problems. You do have answers to these online. You have to bring the pie. You already have yours? Oh, I came twice. Too many yellow sheets. You have to bring the pie. So tomorrow we're going to work on AP problems. The big yellow packet, this packet. Oh, you want one anyway?
No, thank you.
She's already done this. Remember, we are not coming back to this.
Are they cutting down the calculator part? Is that what you said?
Too many ways to cheat. Okay. I don't want that. I always spend a half hour